and welcome to Mr. Meyer's Math Magic. I'm Mr. Meyer, and today what we're going to be looking at is sample space. Now, sample space is a term that's used when we're talking about probability, and what sample space means is that it's all of the possible outcomes. So say this is a spinner, it has these different colors on it. It's when I spin the spinner, what can it possibly land on? So as I'm looking at this spinner, I know that the sample space would be green. So I'll put sample space is green, red, yellow, and blue. So when I'm listing my sample space, I put all of the possible outcomes, which are these 4 outcomes. So whenever I spin the spinner, it needs to land on one of these. There's not a possible outcome that is not listed in our sample space. Say I were to take a die, looking at all of the possible things that it can land on. It can land on a 1, a 2, a 3, 4, 5, or 6. So the sample space for this would be 1, 2, 3, 4, 5, and 6. Now when we're looking at probability, we have the desired outcome as the numerator, and that is over the number of objects or things that are in the sample space. So an example is when we're looking at the die, which has 6 numbers in the sample space, I know that my denominator will always equal 6. So right here, setting up 6 as the denominator. Now say, what is the probability of rolling a 4? So I would put a 1, because there is one number 4 in the sample space, over 6. Now if I'm looking at what is the probability that I roll an odd number, I would look at 1, 3, and 5, and I know that there are 3 possible numbers that would get my desired outcome of it being odd. So I have 3 over 6. I would simplify that to be dividing both by 3, divide that by 3, that equals 1 over 2. When I perform that division, I know that equals 0.5, and if I want to convert that to a percent, because it can be represented as a fraction, a decimal, or a percent, I would multiply times 100, so that it would be a percent. So that would be 50%. Now, sample space is used for all probability problems because that will always be what the denominator is the number of things that are in the sample space. If I take my deck of cards, in the sample space of the deck of cards, there are 26 cards that are red, and 26 cards that are black, and I know the total number of cards is 52. So in my sample space, I have 26 red and 26 black, so I know that the total number is 52. So when I'm looking at what is the probability of me drawing a red card, I know that there are 26 red cards out of 56 cards, 52 cards in total. So I set up that fraction being 26 over 52. I can divide both of these by 2. Divide by 2, divide by 2. That's 13 over 26. Oh, what I realized is I can also divide both of these by 13. Divide by 13. That's 1 over 2, or 0.5 of a chance, or 50%
So as we're talking about sample
space, what I have here are 4 cards. I have 3 red cards and 1 black card. So now, the probability of choosing a black card out of these cards after I mix them up a little bit, the probability of me choosing a black card out of here would be 1 out of the 4 total, or 25%, because it's 0.25 as a decimal, 25% as a percent, because multiplying 0.25 times 100. But now if I look at the cards, so I have 1 black card, 3 red cards. So now all I do is I mix up the cards. And now turning the cards over, looking at all of the possibilities that I can choose from. Now I realize that all I have are red cards, so there's a 0% chance of me choosing a black card. Till I cut the deck, and now looking, and I have my 3 red cards and my 1 black card again. Okay, so in the previous video, you guys were playing a game where it's called Follow the Queen. So now in this sample space, where the only card I have is a red Queen of Diamonds, the probability of me choosing a black card out of this is 0 because there is no black card. But if I just shake the card, making sure to keep it in the frame so that everyone is seeing this, it actually becomes the Ace of Spades.